Hello and welcome to another session. So in this session we will discuss about white box testing techniques. So white box testing techniques are very important, especially for automators, because they are more into the code, and by knowing these techniques they can find more bugs, and they can test the code in the way that can contribute to greater quality. So there generally are two. One is statement testing and coverage. In statement testing, we test the statement in given fragment of the code. In statement testing, we are used to measure the coverage. So coverage is a number of statements executed, our total number of statements in executable code into 100, usually measure in percentage. So other one is decision testing and coverage. So in decision testing, we it is also called a branch testing, because make the decision within the code. So it is 100% decision testing mean 100% statement testing, but not vice versa. So decision testing is more powerful than statement testing. So if we talk about their coverage in decision testing, so total number of decisions within the code that can be if else structure, executed decision in the code, divided by our total number of decision within the given fragment of code into 100, usually measure in percentage. Mm. So as you know, statement testing coverage is in section 4.3.1. So in statement testing, execute the exercise this statement testing exercises the executable statement in the code. Okay, you already know that. So 100% decision testing, decision coverage guarantees 100% statement, but not vice versa. So decision testing is greater than is testing is stronger than the statement testing. So decision testing is stronger. So that's why we can say if there is 100% decision coverage, that guarantees 100% statement coverage, but vice versa is not true. So let's see this example. Here you can see the example. Read A, read B. If A greater than B, print A is bigger, else print B is bigger. And if so, in this case, as you can see in the right hand side, we have flow diagram, and everything is shown in the flow diagram. So here we have statement coverage is 2, because we have two statements, if else. Okay, either we can go towards B or we can go towards A. So in this case we have two statements. So tip for number of else plus 1. So in this case in number of else are 1 and plus 1 2. So in this case statement coverage is 2. Let's see another example. This one says that this is similar example, but question is, what is the minimum number of test cases required for 100% test coverage? So in this case we will require two test cases. So here you can see another example. Second example is read A. If A is greater than 0, then if A is equal to 21, then print key. So you can see this is in this case we have statement coverage 1. So tip for unnested conditions in number of else. So for unnested conditions we have number of else. In this case we have number of else is 1. So statement coverage was 1. Let's see in this we have read A, read B. If A is greater than 0, then if B is 0, then print no values, as print B. If A is greater than 21, then print A, and if total. Nested condition. So in this case we have nested. So in this case tip is number of else plus 1. So in this case statement coverage is 1. We have number of else. In this case we have 2 1 plus 1 2. Here another example, you can see read A, read B. In the right hand side you can see the flow diagrams which shows if A is less than 0, then statement will be executed A negative, else print we run A positive will be shown, and if B less than 0, then print B negative, else print B positive, and if so unnested condition number of else. So in this case if there is unnested conditions, and so test statement, in this case statement coverage is 2. So number of else, in this case we have 2 number of else, that's why our statement coverage is 2. So here you can see the tip. If you have asked these questions, there are shortcut to remember these. For statement testing and coverage, tip for unnested conditions, statement coverage is equal to number of else. Tip for nested conditions, statement coverage is equal to number of else plus 1. So in the statement testing and coverage, here is another example. For a given fragment of code, following path test cases have been executed. What statement coverage achieve? In this case you can see so correct answer is B, 75%. How it is correct? In this case we have test 1 is A B C and test 2 is A B D G H. So in this case totally we have total statements 8. You can see we have 8 A B C, and then we have D G H. 8, we have total number of statements 8. So executed 1 as 6 divided by 8 into 175%, because we have A B. In test 1 we have A B C, test 2 is A B D G H. You can see A B D G H. So in this case 1 2 3 4 5 6 over 8 into 175%. So in section 4.3.2 we have decision testing and coverage. You already know that decision testing or decision coverage test the decision made within the given fragment of code. So decision testing, also known as branch testing or branch coverage. So decision testing is stronger than statement testing. Remember that decision 100% decision coverage guarantees 100% statement coverage, but not vice versa. Here you can see the example. In the decision testing and coverage we have read A, read B. If A greater than B, then print A is bigger, else print B is bigger, and if so in this case we have 2. Decision coverage is 2. So if you are asked what is the number of test cases required for 100% decision coverage, so answer will be 2. So decision testing and coverage, you can see this example. Read A, if A greater than 0, then if A is equal to 21, print key, and if so decision coverage is 3. Why? Because in decision coverage we have number of ifs plus 1. So in this case we have 2 ifs. We have, because here we have nested conditions, so 2 plus 1 3. So decision coverage is 3 in this case. Let's see another example. Read A, read B. If A greater than 0, then if B is equal to 0, then print no values, else print B. If A greater than 21, then print A, and if decision coverage is 4. How this is 4? Because number of ifs plus 1 for nested conditions. So this is nested conditions, so we have number of if 2, we have number of if 2. 2 plus 1 we have number of ifs are 3 and 3 plus 1, because this top one if if a greater than 0, then other if is if b is equal to 0 2, and third if is a greater than 21. We have three ifs, and 3 plus 1 4. So in this case decision coverage is 4. So in this example you can see our decision coverage is 2, because this is the unnested condition. So in unnested condition we have decision coverage 2 regardless number of ifs. In this case we have read A, read B. If A less than 0, then print A negative, else print A positive, and if B less than 0, then print B negative, else print B positive, and if. So remember the tip for unnested condition. Remember, these tips are for decision testing and coverage, not for statement testing and coverage. So tip for unnested condition is decision coverage is 2 regardless number of ifs. So tip for nested conditions is decision coverage is number of ifs plus 1. Let's see this example. For the given fragment of code, following path test cases has been executed. What decision coverage is achieved? In this case, answer is 62%. How this is correct? Because in test A or test 1 we have A, B, C. So in test B we have A, B, D, G, H. So you can see we have total number of branch executed. In this case branch executed were 5. Okay, A, B, C, D, G, H. Here you can see A, B, C, D, G, H, D, G. Okay, we have 5 into 8. Total number of branches, we have total number of branches 8, and executed one is 5. 5 over 8 into 162%. So correct answer is 62%. As you can see in more detail, we total number of branches. In this case we need to look at the key arrows. These are branches. So from A to B we have one arrow, from B to T we have second arrow, from B to D we have third arrow, D to G we have fourth, and G to H we have fifth. So we have fifth decisions. So in this case fifth arrows are covered. So 5 into total number of arrows, you can see, you can count 1 2 3 4 5 6 7 8. So 8. So correct answer was 62%. Thank you very much. See you in the next session. Bye.